Okay, so we just finished watching the YouTube video, What If We Moved Earth, right? And can anybody tell me what the problem is that we saw on the video? What was
I can go first.
Okay, go ahead, Madeline.
The sun will eat the earth.
Will eat the earth. Okay, so why do you think the sun would eat the earth? Or swallow the earth?
Because it's so big and yeah, it's way bigger than Earth.
The video stated a reason why it would get big like that. Do you remember?
Because it's so old and it just keeps growing over time.
Okay, and there's a process called...
I don't remember.
Okay, we're going to go touch base with that again, so in just a second, all right? Miriam, do you want to add anything to that?
That Earth will be in the way of the sun's growth.
Okay, so in 1 billion years, the sun is supposed to get so big because inside it's made up of the gas and these chemical elements, right? And so they fuse together in a thing called nuclear fusion. And when that happens, it produces energy and just gets bigger and bigger and bigger. But eventually, there will be no hydrogen left to form to helium. So it'll just be helium, and then it'll just grow so big that it either explodes or it moves in and it takes over Venus or Mercury and Venus, and then eventually Earth. So there's a big possibility. Mimi, is there anything important facts that you found on the video that you'd like to share?
The sun is a star.
Okay, yes, the sun is a medium-sized star, and it's one of the. It's only a medium-sized star, but it's the biggest star in our galaxy. So it's very crazy to think that that's only a medium star. There's bigger stars.
And other galaxies, because there is other galaxies, there's probably way bigger stars.
Yeah. Just we haven't.
There's one, it's a red one. I heard about it before.
Right, yeah, so that's what happens with the sun. Once it gets bigger, it will turn into a red dwarf. It's a large star. Okay, well, to go further, and I'm going to bring space to us. So we are going to watch an augmented reality, and it's where it puts the sun and the planets right here in front of us. Okay, so we're going to learn a lot on this, and I'm going to stop it as we go and talk to you about some important things that we are learning about through the reality. If you can go to Jigspace, I want y'all all to share this iPad, by the way. If you can go to Jigspace, click on the sun.
Okay.
And click View AR, and then we will begin the augmented reality.
The sun is an ordinary star, one of about 100 billion in our galaxy, the Milky Way. But the sun has extremely important influences on our planet. It drives weather, ocean currents, seasons, and climate. It makes plant life possible through photosynthesis.
Okay, so there is some very important information that they just gave out. What does the sun do for Earth? Marian?
What the sun does for Earth is the sun helps the Earth for us to live, and it helps us eat. It grows plants. It basically does everything in our life to make us live.
Okay, so Marilyn, you want to add to that?
It provides light and energy and food, like heat.
So food is in. How does it provide food? Does it just fall from the sky? There's an apple?
Because of the heat. It's arrays or whatever it's called. It will hit like certain plants and with water and
It's called photosynthesis, right? Okay.
Yeah. Photosynthesis, I thought, was the color pigment though.
Photosynthesis is how the plants grow. It's a process of how it grows. It provides that kind of energy. It forms energy, and that's how the plants grow. Okay, so we can continue.
The sun plays an important role in the ability to form and maintain life on Earth. The sun is the center of our solar system and has a radius of 432,000 miles. That is 109 times the size of the Earth's radius.
Can you stop
The
that?
sun's mass is more than 3.
Okay, so it just said that the center or the sun's radius is 432,000 miles. Does anybody have a clue of how big that really is? Miriam?
The sun is actually bigger than the stars we see at night because it's been around for like more than we say. I was born in the 1980s, and y'all were born in the 1920s. Then mine would be older, so then the sun would be older than the place that then the sun would be bigger for y'all than mine.
Okay, well, actually, so 400, let me go back to my question, okay? So 432,000 miles, that is a lot. So from here in Katy, Texas to Disney World, let's say, that's in Orlando, Florida, is about 1,000 miles. Okay, so if we went back and forth from Disney World to home, 432,000 times, that would be how much? Just from the sun's core to one of its outer edges. Okay, so that's just the center of it to the outer edge. So your family is from Iraq, right?
Mm-hmm.
So Iraq, how long do you think it takes to get to Iraq on the plane from here?
About 15 hours?
About 15 hours.
17.
Okay, when I looked at some of the flights were like 19 hours, so that was a layover. But the mileage from here to Iraq was about 7,300 miles. So still, it's nowhere even close to how big the sun is. And Iraq is pretty far away. I'm sorry?
And that's like only the radius.
Yeah, it's only the radius of it. So it's just to put that in your head to just try to imagine how big the sun really is, okay?
What's radius?
Oh, what is radius? Why don't you tell me?
Oh, okay. Radius. So if you have a sphere, which for the sun in this case, the middle of it to this point, only half of it, that's the radius. If you have the whole half of across the whole thing, that's the diameter. But right now you just have your radius.
Yes, and that's something you can also
So,
learn in math.
If you have your radius here, that's only here. Like only this half. And then if you want the whole thing, then you would times it by 2 to get your diameter.
Thank you.
Mm-hmm. Okay, so let's keep going.
Okay.
The sun, like Earth, has many layers. Starting from the very center of the sun, we see the sun's core. Next is the radiative zone, and then the convection zone. The outer layers are that of the photosphere, the chromosphere,
Are you drawn
and the corona.
Very good. That's a good idea.
There have been various advances in technology throughout history that have allowed us to study the sun, therefore becoming familiar with its properties. Infrared telescopes were invented.
Okay, so on the video that we watched, what was a plan that they described to us to be able to move the Earth? Myrna?
Rockets around the sun.
Rockets.
Around the whole Earth.
So, and that would do what exactly?
It would make it like orbit, like almost like it would push it out this way, but still keep it going in a circle.
Right. So, Now, they just continuously are coming up with different ways of exploring outer space. And just recently, within the last few years, they actually got a satellite that could actually go outside of the galaxy. And the galaxy, on average, could take a person 44,000 years to get out of.
Wow.
Yeah, so, but the satellite finally went past. It was the Voyager 1 and Voyager 2. Okay, let's continue.
Okay. I think we're right here. Or we're...
There's 2 different slides like that.
Okay, so it's this one.
Survived 1 was the first spacecraft designed to study the sun. It was launched by the United States in 1960. That decade, the U.S. Space Agency NASA sent 5 Pioneer satellites to orbit the sun and collect information about the star. The Solar and Heliospheric Observatory was developed in Europe and put into orbit in 1996 to collect information. It can forecast space weather.
I paused on some.
The sun is made up of a blazing combination of gases. 3/4 of the sun is hydrogen, which is constantly fusing together and creating helium by a process called nuclear fusion. Helium makes up almost the entire remaining quarter. A very small percentage of the sun's mass is made up of other gases and metals: iron, nickel, oxygen, silicon, sulfur, magnesium, carbon, neon, calcium, and chromium. See if you can locate these on the periodic table. The sun has
Okay, so we just learned about nuclear fusion. Does anybody know what that is? Miriam.
Nuclear fusion is...
Let's not raise our hand unless we know exactly what we're going to say, okay? Let's think it through before we try to answer. Go ahead.
Nuclear fusion is hydrogen converting to helium.
Okay, and so when the hydrogen mixes with helium, the helium gets really hot. And when that happens, so hydrogen and helium, it forms mass, right? And that mass turns into energy. Okay, so that's how we get our light and our energy here, and how photosynthesis starts because of that nuclear fusion. And the nuclear fusion, it happens in the core of the sun. Okay. And again, do y'all remember how much of the sun is hydrogen?
I don't remember.
99% of the sun, or actually 74% of the sun is hydrogen.
Okay.
And the other quarter, almost the rest of the remaining quarter, is the helium. And then there's just about 1-2% of the other chemical elements. So those 2 things, that's why there's a possibility of it forming together, and there goes Earth. Okay, let's continue on.
Oh, sorry.
We will now use the new knowledge of the sun's properties, its role in the solar system, the contribution it makes to life on Earth, and the understanding of gravity to create. The sun is an ordinary star.
Okay, we can stop it. Okay, so we've learned a lot, and we're going to take what we've learned off of our jig space here, and we're going to apply it to our anchor chart, okay? So y'all are going to help me fill this out, and I want y'all to pay close attention, because whatever we do on here is going to help y'all at the end. We are going to be doing a project, okay? So let's get started. Let me get a marker.
If there were
here, but we go this way.
Thank you. Okay, so let's start with some of the characteristics of the sun, right? So both the video that we watched at the beginning of the day and our jig space told us many different characteristics of the sun. I would like to hear what y'all remember. Who would like to tell me? Miriam?
So what did you say about the sun?
the characteristics of the sun. What are some important facts about the sun you think we should add to the poster?
That
What did you write down there?
I wrote that the sun plays.
Okay, but what you said it was earlier that it was what
It was a bigger star than all the stars that we see in the night.
So it's a medium-sized star, okay? So we're not going to add that to here. So it is a star. You were correct about that. So a medium-sized star. Okay, another fact? Mimi, what do you got?
It's the center of our solar system.
Very good. It is the center of our solar system. Anything else that you think is important to add? Marnolin?
The sun takes up 99% of our solar system.
Yes, so that means that the sun is gigantic, and our solar system is huge too, so it takes up the majority of it. So, the sun's mass, let me correct you.
The sun's
mass is 99% of our solar system. So that means it's the biggest thing here. Another fact. Yes, Mimi.
The sun is made up of gas.
Yes, it has hydrogen. Made up of hydrogen, and do y'all remember what else it was?
And helium.
Helium. Good job. Okay. Marlon?
It's already up there. Sorry.
What?
Oh, I know one.
Oh,
It has layers.
very good. Do you know how many layers it has?
7.
Seven layers that we'll focus on. But for right now, so the sun has many layers. One is the core, which is the main one that we will focus on today and throughout this, because that's where nuclear fusion takes place. But so the sun has many layers: the core, the radiative zone, the convection zone, and all of these are the inner layer. These 3 layers are the inner layers of the sun. So the core, the radiative, and the convection zone. And then we also have, does anyone know? Yes.
We have the chromosphere.
Chromosphere. Okay, so but we're gonna do the photosphere first.
Okay.
And then the chromosphere.
And then the last one.
And what's the last one?
It's corona.
Corona, and not COVID corona. Completely
Coronavirus.
different. So corona. Very good. Okay, so let's see. We got a medium-sized star. It's the center of our solar system. The sun's mass takes up about 99% of our solar system. The sun is made up of hydrogen and helium, and the core has many layers. I think the only thing that we're missing is what influence does the sun have on Earth? Yeah,
What is it, 5?
exactly? Okay, Mimi?
It is basically the main heat source.
Main heat source, very good. So we got that. So the influences equal heat. What else is there?
There's
Yes.
light.
Light. Mary, what did you want to add?
It takes 99% of the sun's mass.
Already wrote that.
We got that on here already, but thank you. But you were talking earlier about how the sun provides food. Do you remember what I called that? Photosynthesis. It's a hard one. So we do, it has photosynthesis. So
Sometimes I get confused.
it's okay. So the sun provides us heat, provides us light, provides photosynthesis for plants to grow. It also affects the weather and the climate and the seasons. I mean, it has a lot.
Yeah.
Mhm. So let me write that on here. Seasons, climate, and weather.
Like tides and
All that plays a big role. So there's so much more we can go into with the sun. So on your project, you will learn even more.
about
But
that.
I want y'all to find it, and y'all come to me and tell me the new stuff that y'all find. Okay.
Yes, ma'am.
All right. So we added some very important features here. Let's move on to gravity. Now we've learned about gravity since we were in what?
Kindergarten.
Yeah, everybody
Before that.
knows some things about gravity. So I want to see what y'all know. Miriam.
That gravity, say, like me and Merlin, we were in space and there was no gravity, then we would probably fall down.
So does space not have gravity?
It does have gravity.
Okay, just making sure that you know. Okay.
so adding on to Miriam, if we were in space because of the gravity, like space has less gravity and it has not as strong gravity, so we're not gonna fall, we're still gonna float, but gravity holds us to Earth's surface.
Okay. So so if I'm standing here, okay, and I'm on Earth, okay, so obviously the gravitation on Earth is making me stay right here, right?
Yeah.
But what if I was holding on to something else and let's see, or like pushing on the wall?
If that's a force, the wall would be pushing back to you.
Okay.
Pushing back.
Very good. So, so technically that means that if I am pushing on the wall and the wall is pushing back onto me, that gravity is what?
Gravity is I can't put it.
Okay, you said force. So a force that attracts another body or object toward another physical body or object. So forces attract each other. So gravity, the bigger the object, the bigger, like the sun, it's going to attract all these other things because it's like almost like a magnet, you know. So here's this big giant sun and it's huge and massive, right? And so everything is drawn to it. But if we stay a safe distance, you know, it's just like kind of just keeps us going like this. But if it got a little closer, then we'd be like, right?
We would just get swallowed.
Well, I'm just in magnets in general. That's how it works, right? The closer you get, the greater the attraction becomes, the greater the force. So it's hard to, you know, when something's pulling you, if it's way bigger than you, how are you going to get away from it? You know. So let's write that down. So force. Gravity is the force. Force that attracts. A body to another physical
body.
Having mass. Yes, Mimi.
On Earth, gravity pulls you down, so.
Okay. So, let's see. So what would that be called? What is that? There's a word for it.
Gravitational pull.
Very good. Yay. Yes, it's gravitational pull. So the gravitational pull, what is that? What determines gravitational pull? Like, why are we connected to Earth? Like, why is Earth pulling us here? Why aren't we pulling on Earth?
Because the Earth has bigger mass.
Very good. Yes. So gravitational pull is determined by the size and the mass of an object, right? Okay. So let's write that down. The size and mass of an object or the planet or anything like that. Determine its gravitational pull. Okay. Yes, Miriam.
And gravity, it is a plane's size and mass determines its gravitational pull.
You told me we got that on there, but you told me something the other day, and I'm gonna bring it up. Actually, it was earlier today, and you said that the Earth does what around the sun?
The Earth goes around the sun so slow.
But what do you call that?
It orbits.
Very good.
Orbits the sun.
And so, do you know why it orbits the sun?
Yes, because the reason why the Earth orbits the sun is so we can have more food.
Okay, but we call that, it's because of the
sun.
gravity.
Gravity.
So the force that creates the force from the sun and the Earth, it's the gravity. Okay, so that's why we are staying in that orbit around it. So it's the force that keeps the planets in orbit around the sun. Okay, so I'm gonna add that on there. Let's see. All right. Okay, so we got quite a few facts on here. I'm running out of space, so I think it's time for us to move on to nuclear fusion. Okay, so nuclear fusion is fun. Can anyone tell me what they remember about nuclear fusion? Marion?
I remember that nuclear fusion is the core of the sun and is made of permanently of hydrogen and helium as.
Wow. Okay, so let's slow down. So nuclear fusion happens in the core of the sun, right? So happens in the core of the sun. And how does that happen?
It happens.
You just said hydrogen and
helium as hydrogen.
Miriam. Here, I think Mimi might have it. Let me see. Let her go because you gave us a fact. Now we're gonna let Mimi give us a fact. Okay.
Hydrogen.
So hydrogen converts to helium, right? So hydrogen gets to helium, and the helium heats up so much that it turns into
energy.
Yes. Okay. So and hydrogen, helium,
or it's mass, and
they turn into hydrogen and helium are a form of a mass. They create mass. So hydrogen and helium equal mass, and then the mass turns into energy, right? Okay. All right. So let's move on to mass. And So can anyone tell me what they believe mass is? Miriam.
Weight or size an object takes up.
So like the amount of space it takes up is what mass is. Okay. So our mass.
And also, like, say I had a tall man beside me, and I was 1 feet and he was 6 feet. Then he would be taller than me because.
So would he have a bigger mass than you?
Yes.
Okay. So just like the sun has a bigger mass than Earth, is that what you're trying to tell me? Okay, good job. So we can say, so the greater the mass, go ahead, Mimi.
The greater the mass, the greater the strength of gravity.
Very good. So write that one here. The greater the mass, the greater the strength of gravity. So that's why we orbit the sun, because the sun has greater mass, so we all just orbit around the sun because it's got the larger gravity, right? That gravitational pull. So I want to give you, so Miriam said that the mass was considered the weight and the size of space it takes up. Okay, so it's a physical matter, is what we would call it. It's the, let's see, let me try to word it. It's the quantity of physical matter. So physical matter. So quantity of physical matter. Okay, that's what mass is. It's the amount of something, you know. Okay, anybody else?
I said the sun's gravity pulls the sun because the sun's mass is so large.
Right. So I just said that, didn't we? So because the sun is so big, and so massive, it brings everything to it. The gravity is so big. So give me just 1 second, okay? So the sun's gravitational pull is what? Is greater?
Yeah.
Because of its mass, huh?
Yeah.
Okay. You got another one?
Mm-hmm.
Okay.
Okay. The sun consumes over 99% of all mass in our solar system.
Okay, so the sun has consumes over 99% of the solar system, right? All the mass in the solar system. So the sun's mass consumes over 99% of the solar system. Okay, that's a lot of good information. I hope that y'all use this, because now I'm going to have y'all form groups. You three can be together if you have like, but we are going to use our problem-solving models that we used in math. Okay, in math, what do? We identify the problem. Okay, we go and we explore some alternatives. And then we select an alternative and we try to figure out if that solution is going to work, right? Okay, so I'm going to give y'all each one of these.
Thank you.
And I'm going to do the first part with you to get y'all going. first thing that we want to do is we're going to identify the problem. So what I'm going to have y'all do is y'all are going to create a project. So we figured out a problem in the very beginning. And the problem was that in 1 billion years, the sun could actually swallow Earth, right?
Mm-hmm.
So that is our problem. We're going to write it right here in the first little box. So write that down. The sun could swallow Earth, right?
Mm-hmm.
So the sun could swallow Earth. That is our problem. All right. We need to find a solution. How are we going to stop this from happening? How are we going to save the world? Now, I'm going to have y'all can use the iPads, y'all can go to the library. Y'all's job is to find different solutions. And then we're going to put them into effect and see which ones we think that we can make work. And y'all will design a project over that and present it to the class, okay?
Okay.
Mm-hmm. All right, let's get started.